Action. A murder victim is found at 9 p.m. The temperature of the body is measured at 90 degrees Fahrenheit. 1 hour later, the temperature of the body drops to 89 degrees. The temperature of the room has been maintained at a constant 70 degrees Fahrenheit, and the victim's normal temperature was 98.6 degrees. Assuming that the temperature T of the body obeys Newton's law of cooling, write a differential equation for T, and then you're going to solve the differential equation to estimate the time of the murder. So let's do this. All right, Newton's law of cooling says the rate of change of the body with respect to time is directly proportional to the difference in those two temperatures. So the body temperature minus the room temperature. What was the room temperature?
70 degrees.
70. Very good, class. This is a very smart class. Okay, now, yesterday's lesson, we learned to separate our variables. We separate our variables. So it's going to be 1 over b minus 70 dB. All the variables with a b in it. So all the parts of our equation with b. And then we have our constant k, and I'm going to get that dt over to this side. That's our separation of variables. Yesterday's schema. Okay, now, the next thing that we do, Sarah, is what?
You integrate both sides.
You integrate both sides. Very good. So, Sarah, make me proud. And what is the antiderivative of 1 over b minus 70 with respect to b?
Ln of the absolute value of b minus 70.
The ln of the absolute value of b minus 70. And then, what is the antiderivative of k with respect to time?
Kt plus c.
Kt plus c. Very good. Any questions so far? Everybody's cool? Okay, Joe, how do we eliminate an ln?
You eat both sides.
You exponentiate both sides of your equation. What is so funny? Exponentiate, you like that word? All right, anyway, what happens to the e and the ln? They blot out, and you get b minus 70 equals e to the kt plus c. Now, this is the biggest mistake that my kids forget to do right here. What do we do with this e with the plus c in it? You separate it as e to the c. And e to the c is just a constant. So I'm going to put that e to the c out in front of my e to the kt. Now we have to use some initial condition. The initial temperature of the dead body at 9 p.m., so I'm going to call that time t equals 0, was what?
90.
These detectives found the body and they took the temperature right away. It was 90 degrees. Then 1 hour later, they said, we better get another temperature reading of the body. And it was measured at 89 degrees. So it's losing about a degree per hour. And we're going to use that initial condition to solve for our constants. So, is the body temperature warmer than 70 degrees?
Yes.
Yeah, so I'm going to eliminate the absolute value. So, b minus 70 equals e to the c times e to the kt. If I put in 90 degrees, what's 90 minus 70? 20 equals e to the c. Then if I put in 0, what is e to the 0? 1. So e to the c came out to be 20. So I'm getting closer to my differential equation. b minus 70 equals 20 e to the kt. Any questions so far? Okay, now we're going to use our second piece of the puzzle. After 1 hour, the body temperature dropped to 89 degrees. So 89 minus 70 equals 20 e to the what? E to the 1k is just e to the k. So this is 19. If I divide out the 20, I get that. Somebody who took the natural log of both sides, tell me what k came out to be. Raise your hand. What'd you get? 0.0513. Positive or negative? Negative. Very good. Low, low. All right. So now we have our differential equation. b minus 70 equals 20 e to the negative 0.0513t. Right? Did I miscopy that? No. So there's our differential equation. We want to know when this murder took place. So what was the body temperature when this guy was alive? 98.6 degrees. So you're putting in a 98.6 degrees in for B. And then you guys, to save time, what you get for your time? Anybody? Bueller? Anyone?
Actual time or how long?
What was your T?
6.97.
Good, negative 6.972. So about 7 hours before the detectives found the body. They found the body at 9 p.m. So the murder took place at 2 p.m. I'm very proud of you guys. A lot of you guys got that right. Come on.